Max. Good morning. Good morning, Max, Israel, Emma, Clarissa. Good to see you got on. If any of you could let me see you, that would be good. Hi, Clarissa. You can you unmute yourself for a second? Yeah. Hi, Clarissa. Able to join from the classroom?
Yeah.
Okay. Were you trying to do something else?
Too early.
Okay. Oh, okay, so the meeting wasn't open?
Yeah.
Okay, Clarissa, can you do me a favor while you're unmuted? Can you see the screens okay?
Yeah.
Okay, thank you.
Welcome.
We have a couple of minutes, actually 1 minute. Anyone want to ask me something? 1 minute. All right, good morning, everyone. I hope you guys are hanging in there. It's good to see you all. Once again, thank you for muting yourself at the bottom. Feel free to unmute yourself if you'd like to make a comment or say something. I do have some housekeeping things that I want to talk about, but I want to wait until all the late students come aboard because they're probably the ones that need to hear it the most. So what I'm going to do is I'm going to start the lesson and then I'll stop the lesson and talk about a few housekeeping things. I hope you're all well. It's good to see you again. All right, so in 15.2, this is California Common Core Standard F.BF.3, and we're going to look at graphing logarithms, and we are going to be graphing logarithms just like we did with transformations. So it is important that you do the Explorer. Also, I should tell you, I know you have my notes, but eventually you will not have my notes. So if you look at your textbook, the pages for the assignment are a PDF. So if you have a printer, print out the notes so you don't have to be going back and forth. You will have to take notes from me, but it might be useful to have the book notes, the lesson next to you if you have a printer and can print that out. If you can't, then that's okay. But eventually you'll have to take notes when I give them. So in this case, you want to make sure you do the Explorer because it does explain how to graph simple logarithms before we get into some heavy stuff. So just like the exponential function, remember 2 to the x, 3 to the x, 4 to the x, 1/2 to the x, 1/3 to the x. Remember all the parents were different? Well, because the logarithm is the inverse of the exponential function, all the parents will be different. So let me just show you real quick. So you could have a parent that looks like log base 2 of x. You could have a parent that looks like log base 1/2 of x. You could have a parent that looks like log base 7 of x, and so on and so forth. These are all parents. So in the Explore, they are talking specifically about parents. So make sure you do it. So for example, if you had y equals log, you guys remember what the base is? I think we talked about this last time, right? So when you don't see a base, there's a base there. So you wouldn't read this log of x. This is log base, what?
10.
Right? So it's log base 10 of x. So if we were going to find the parent points in order to do the transformation, remember that with the logarithm function, we're going to find 2 points, and you want to remember that there's a vertical asymptote at x equals 0. So that's the information you're going to transform from. So if you were to pick x's here to graph this, what would you pick? Well, one thing you'd want to pick is 1. Because last time I told you, I gave you a logarithmic a property, and I said log base b of 1 is always 0. So log base 10 of 1 is 0. For the other point, you would want to use the other property that I gave you, which was log base b of b to the x equals x. So if you had log base 10, you would want x to be 10 so that you have log base 10 of 10 to the 1 is 1. So therefore, if you want to graph this, I'm going to do a few of these. You would want to label your axes, but take the x out to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and graph the points. So you do have a vertical asymptote at x equals 0. And I think we talked about this briefly before. What's going to move a vertical asymptote? It's going to be h. So right 3 is going to move the vertical asymptote right 3 when we get to it. Left 4 is going to move the vertical asymptote left 4 when we get to it. So you graph these points, right 1, 0, and then right 10, up 1. And so what you have is you have the inverse of exponential growth, which looks like this. And this is the graph is it goes up forever. It's going to go like this, and it's going to fall along the vertical asymptote without hitting it. So if you looked at the domain of this, the domain is open on 0 to infinity, and the range is all real numbers. This does not flatline. This goes up forever, so it's going up forever, and it's going down forever. Let's do another problem. Anybody want to ask me about this? I'm going to leave those properties up there because we are going to use them. Looks like my board is erasing a little better today. It's getting used to me. So another example would be y is equal to log base 4 of x. It's a parent. So once again, we have a vertical asymptote at x equals 0. And we're going to pick 2 parent points. So what would the 2 parent points be? Well, once again, we like 1 because 0 isn't going to help us out here. We don't know anything about log base 4 of 0. But we do know about log base 4 of 1. Its y value is 0. And what would be the other x we want to pick? would be 4. So what we have here is log base 4 of 4 to the 1 is 1. So once again, I'll just do the graph real quick. The next one, I won't do the graph. Once again, you have a vertical asymptote at x equals 0. You graph the points right 1, 0, 1, 2, 2, 3, 4, up 1. And there would be your logarithmic function along the asymptote. Once again, it flips over the identity, and its inverse is y equals 4 to the x. So that's its inverse, its exponential growth. All right, the next one I'm going to do, I'm not going to do the graph for unless you want me to, but it'll be log base 1/2 of x. So once again, we have a vertical asymptote at x equals 0, and the parent points would be what? Well, right now we love the number 1, so log base 1/2 of 1 would be 0 because of this property. And then we like the base of the logarithm to be the base of the exponent because it undoes itself. And so we want to choose 1/2 because log base 1/2 of 1/2 to the 1 is 1. So once again, you would draw the graph along the vertical asymptote. Once again, this is a parent. And it is the inverse. The logarithm is the inverse of the exponential decay function. All right, anybody want me to do the graph? Just unmute yourself and let me know. Anybody want me to do the graph? Okay, can I have a thumbs up that you're okay? All right, thank you. I'll leave those up there. Okay, what I'd like to do right now, hopefully everybody's on board at 8:10, and I want to talk about a few things, and then I'll come back to teaching the lesson. First of all, I want to thank everyone who has helped me just do things and give me feedback, because a lot of what I'm seeing is not what you're seeing. So when somebody says, hey, we can't follow those directions because that's not what we see on our end, that's very helpful to me. So I really appreciate that. Also, I want to thank all of you who have written me, either through Remind or through email, telling me that how things are working. And I really appreciate that a lot, because I've been skeptical about what I'm doing. And so it just gives me the courage, and the confidence to go on the way I'm going on. So I appreciate that. Practice exam 15.1 is due tonight at 9. You must do it, because I'm doing this practice exam to make sure that you're going to be able to do the exam, which is in the very near future. So remember that we only meet twice a week, but you don't have problems twice a week. You have problems 5 days a week. And so it's going to take a lot of self-discipline, and you have to stay on top of things. It's actually harder in some cases because you have to hold yourself accountable. So you're probably going to have an exam on Monday morning, or Monday afternoon. So I would make sure that you're doing what I want. And so the practice exam 15.1 is due tonight at 9. I'm trying to see, can you get into my HRW? Can you take the exam? Can you turn in your scratch work? Because when it comes exam time, you're not going to have that leniency. You have to take the exam when it's due. You have to be able to get in there. You have to be able to turn your scratch paper. So we're practicing now, not later. We're practicing now. So the other thing is, if you notice, I have a lot of due dates at 9 p.m. You're not waiting till 6 to do your assignment. I'm giving you that leeway so that if you have problems in the afternoon, you have all that time to try to resolve things. So don't wait till 9 o'clock to do your assignment. You must do it at the same time you normally do your assignment. I'm just making it 9 o'clock so you have some wiggle room. Also today at 9 is assignment number 36. Make sure you turn it in. Make sure you do it. You should already have it done pretty much. You had the whole weekend to do it. I'm going to interject this real quick. If you notice that in the stream, it's showing the lessons. I mean, the lessons is not showing the assignment numbers. So I think what I'm going to do is I'm going to get rid of the assignment numbers and I'm just going to give you the lesson numbers. I think it's just going to eliminate a lot of confusion. You know, the fact that assignment number 36 goes with lesson 15.1. So in the classroom, you will see lesson 15.1 rather than assignment numbers. It's just causing confusion. It's causing me to be confused. So I'm going to try to change that. Also, if you noticed, I put up assignment, I'm going to change to 15.2. That's due on Thursday at 9. So that's this lesson. And there's work to do. I think I assigned the book work. I assigned problems out of the interactive textbook. And I also assigned pages that I added that I took pictures of from my phone for extra graphing. So there's 3 different parts to that assignment on Thursday. Make sure you do them. At the beginning on Monday, when we had the welcome presentation, I asked you to go to my HRW and mess around in there. So you're familiar with what's going on. A lot of you didn't do that. I know that because I can see what you're doing on my HRW. I can see that some of you have never logged on. I can see exactly what you're doing. So a lot of you didn't follow directions and get into my HRW and mess around in there. So I need you to do that. So what I did last night is I put the directions for maneuvering through HRW in my HRW in the classroom. So if you look, I put a big lengthy list of directions on what to do. So if you're confused with my HRW, look at my directions in classroom under my HRW. Also, I need you to follow directions more than ever before. So everything that I'm doing is setting you up for something else. So it's very, very important that you're doing what I told you. I still have people that haven't turned in the verification letter. Well, the verification letter was that assignment was necessary to make sure you know how to take a picture and upload it to Google Classroom. If you can't do that, you're not going to be able to do your exams. It's very important that you do the verification letter. You're not exempt from it. So, let's see here. Yeah, so the exam that I'm going to give you, I'm going to mention this again. The exam that I'm going to give you, which is probably going to be next week, it's going to require that you're able to not only take the exam on time, but that you are able to take pictures of your scratch paper and submit your scratch paper from your phone to Google Classroom. So I've done a few things now to get you set up for that. So hopefully you're staying on track with things. All right, I do want to mention the goal of this course right now. The goal of this course right now is to raise your grade, number 1, and number 2, prepare you for honors pre-cal. So if you've been watching the news, you've seen a lot of kids aren't attending class, kids aren't showing up. You can do whatever you want. So, you know, my neighbor was asking me about this yesterday. He said, you know, are your kids showing up? There's a big problem with that. I said, well, my kids know that if they don't show up, they're not going to be ready for honors pre-cal. So it's sort of like you either pay the price now or you pay the price later. So if you're having, you know, a good old time and you're not doing what you're supposed to be doing, good luck with honors pre-cal, because in honors pre-cal, there is no review. We start right in with honors pre-cal. And so there's no review. So everything that I've done with you, all the different lessons I've given in infiltrating inputting things like adding and subtracting fractions, solving a simple equation, the order of operations, none of that in honors pre-cal. That's true honors pre-cal. So you either prepare now or you suffer later. And I'm not sure if you want to sit in your honors pre-cal class with everybody knowing what's going on except for you. So stay on top of stuff and make sure you're doing the assignments. Make sure you turn your work in on time. All right, I'm being patient. I'm not talking to people who are having technical problems. I'm not talking to people who are trying their hardest. I'm talking to those of you who are being lazy and causing me a lot of work. So in the very near future, I'm not going to send you little notes. I'm not going to send you little reminders. I'm not going to take late work. So stay on top of things. Please turn your work in on time, just like we did in my classroom. Next thing, make sure you get the Remind app. So I've noticed that it's very easy for me to communicate with you through Remind. So now I was making it voluntary. You have to get the Remind app now because I am communicating with messages that way. So the Remind app, if you need the code, let me know. Also, you need to let me know about anything personal that's preventing you from doing what's required. If there is something going on, if there's some type of emergency, let me know. Otherwise, you're going to be held accountable for what I'm requiring and the time that I'm requiring it. Also, let me know about things on my end of it. I'm not working on a Chromebook, okay? I'm not working on a phone. I'm working on a laptop. So if there's something I'm doing that's not matching what you're doing, let me know so I can fix it. And with this, don't send me messages at the last minute. Right now I have a pre-cal. The pre-cal class is taking a test this morning online. Someone's sending me a message right now and it's 20 minutes after the test started. Can't work like that. So when I say last minute, I'm talking about an hour or two. I'm not talking about 15 minutes. You cannot, I can't work like that with this online stuff. So don't be doing things at the last minute and sending me messages at the last minute. Okay, and finally, you are going to take an exam, 15-1, 15-2, and it's going to be on Monday. All right, so I'm planning on it being at Monday at 2:30. If you cannot do that, you need to let me know. All right, so that's the plan right now. Monday at 2:30. Just let me know. Another possibility would be Tuesday at 2:30, but I don't want to take time during, I don't get to spend that much time with you, so that the exams cannot be given during these lessons. So there has to be other times we could take them. I thought about doing it during the tutoring times, but you should be available at 2:30 on Monday. If not, just let me know and we'll figure something out. So 15-1, 15-2, it will be an online exam. You have to be able to get there. You have to be able to take the exam. You have to be able to submit it. And you have to be able to send me your scratch paper. All right, so get with it. Take the practice exam that I set up for 15-1 to make sure you know what you're doing. All right, anybody have any questions? All right, if you look at your notes then, I'm not going to write this on the board. I'm going to move on here, but I asked you to recall domain and range, which you're pretty good at now. I asked you to recall in behavior, which you're pretty good at. Vertical asymptotes and horizontal asymptotes. X-intercepts are an ordered pair. Y-intercept is an ordered pair. Remember, decreasing interval is the domain where the graph is going down. And increasing interval is the domain where the graph is going up. Negative interval is where it's where the graph is below the x-axis, and positive interval is where it's above the x-axis. All right, so starting the lesson with objective 1, we are graphing the logarithmic function and we are doing transformations on it. Write this up here. remember I talked about the logarithm showing up in different levels. This is a subscript. If there was a power, it would be a superscript. But all of these other letters fall along the same line as the logarithm. So you can probably guess what these are. Hopefully, the Common Core Standard says that students will know what A, B, H, and K do to the graph. This is a little bit different because this right here, this is not a horizontal stretch of compression. In fact, if I were to write it the way we're used to seeing it, I would make this log base F, and your B would be here. The letters don't mean anything. It's the position of the letters. So this would be your vertical stretch of compression, reflection over the x-axis. This B, which you're not going to see, that's why they didn't put it in the definition. This would be a horizontal stretch of compression and reflection over the y-axis. That would be your left or right. That would be your up or down. So let's just take a look at a problem. -1. -2. They didn't start out easy. You know, they know you've been doing a lot of transformations, so you should be able to state the transformation. So we'll just do it out loud. So if you want to unmute yourself, we can just do it all together and see if we get like a really loud thing going on. You want to make sure you do it in the right order. So let's just see how this works. Everybody unmute yourself. Ready? All right.
Right one.
Right one.
Right one.
Right one.
Good.
Right one.
What would be next?
Left, right.
Stretch.
Stretch by two.
Stretch by 2.
Reflect across the
X-axis. Left
X-axis.
And
down
down.
two.
Would be
two.
down 2. That was interesting. Okay, go ahead and mute yourself. So I would write that down like we normally do. And then you're going to write down, well, we're going to look at the parent. So the parent would be your most simple graph, log base 2 of x. We just did some of those in the Explore. So you do have a vertical asymptote at x equals 0, and you're going to pick 2 points. So we're going to pick 1 because log base 2 of 1 is 0, and we're going to pick 2, log base 2 of 2 to the 1 is 1. So we're not going to graph those. We're going to do a transformation with those. So I'll just do it here for the sake of not having a big board. So we're going to go right one first. So right one would be 2, right one would be 3. Just shout out if I make a mistake. Vertical stretch should be the y value. So multiply by 2, multiply by 2. Reflect, so reflect over the x. Remember that's negate the, the y? So this would be 2, 0. This would be 3, -2. And then finally, down 2 would be 2, down 2, 3, down 2 would be -4. And then we graph. Okay, if I were you, I would draw the vertical asymptote right away. So draw the vertical asymptote right away. So our parent vertical asymptote was x equals 0. But now we have a new vertical asymptote. And this right one moved him. So your vertical asymptote now is x equals 1. Got that? Give me a thumbs up. Yeah? Okay. And then we graph the points. So right 2, that was 1, 2, down 2. And then right 3, down 4, 1, 2. Now that is scary. It's like, wait, whoa, hold on just a second. Well, what's going on here? Well, you want to remember that your parent logarithm always looks like this. So it's sort of like square root, but it goes forever down. All right, so that was your parent. Remember, you reflected him over the x-axis. So if you reflect this over the x-axis, shouldn't he look like, good place to put him. Shouldn't he look like this? Oh, you can't see it on this bar, huh? Well, he should look reflected, right? He should look like this, flipped over. So if he looks like that flipped over, that's exactly what we have. We have the logarithm going up along the asymptote like that. So that's a reflection of the parent over the x-axis, and of the transformation, of course. So if we were to state the domain, what would the domain be? It'd be open on 1 to infinity, and the range would be forever up and down. So remember with the exponential growth and decay, it was the domain that was forever left and right. So see how they're just switched? So the inverse, the domain and range for the logarithm are just switched from the exponential growth and decay functions. All right, go ahead and open up your mic if you have a question. So any question about anything?
Back on the graphs that were log base 1/2, why were the graphs like this one?
Because they're remember the exponential function that was x to the 1/2 power. Remember that was decay. So remember exponential growth went up and decay went down.
Oh, okay.
That's why. Remember that if you have a whole number greater than 1, it's going to, remember it was exponential growth. And remember if it was a fraction between 0 and 1, like 1/2, 1/3, 7/8. Remember it was decay.
Mm-hmm.
Well, the same thing's going to happen with this logarithm. So right now, that right there, that would represent its inverse as exponential growth. But if that logarithm becomes log base 1/2, then its inverse would have been exponential decay.
Okay.
Does that help?
Yeah. Thank you.
All right, you guys want to do another problem? Another one? Thumbs up?
Yes.
Say something? Okay. Should train my cats on how to erase the board for me. They're walking around my feet because they're jealous that I'm talking to you. Teach them how to erase the boards, that would help. Let's try. Okay, so 2 times log base something. All right, somebody open up your mic and tell me what's the base of this logarithm?
10.
Yep. So this is 2 times log base 10 of the quantity x plus 2 plus 4. So, since you have my notes, I won't write down the transformation. We will say it, but let me write down the parent right now. So the parent is log base 10 of x. If you want to, you can put a 10 there, but at some point you shouldn't have to. We have a vertical asymptote at x equals 0, and the 2 points we're going to choose are x once again being 1. So you have log base 10 of 1 is 0. And then we have 10. So that log base 10 of 10 to the 1 is 1. All right, so let's state the transformation. I like that last time we opened up our mics because it was really loud and obnoxious. So let's open up our mics again and state the transformation. Ready? What is this?
Left
Left
2.
2.
Left 2. What is this?
Vertical
Stretch by 2.
Vertical stretch by 2 and
4.
4. Good. All right. So here we go. We're going to go left 2. That doesn't affect the x, so I'm sorry. All right. So left 2 would be what, -1? And left 2 would be what, 8? Correct me if I'm wrong. Vertical stretch by 2. 2 times 0, 2. And then we're going to move up 4. So up 4, up 4. And now we no longer have a vertical asymptote at x equals 0. It's been moved what? Somebody say it.
Left.
Yeah, twice.
Left 2? Yeah. So it's a vertical asymptote, but it's being shifted to left 2. Is that correct? Give me a thumbs up. Okay, thank you. Board's still wet. Okay, I'm going to draw that out a little bit. 1, 2, 3, 4, 5, 6, 7, 8. Okay, here we go. So like I recommended before, draw the vertical asymptote. So the vertical asymptote is at x equals -2. Left 1 up 4. Right 8 up 6. So is this 8 up 6? Ooh. There it is. Okay, this time we know the parent looks like this, and there is no reflection. So he should look like the parent. And he does. He goes up forever slowly, but he comes like this, and he runs along the vertical asymptote. All right, let's state the domain and range. What's the domain? Open on, used to you guys answering. Open on -2 to infinity, and the range is forever up and down. Now, by the way, in your lesson, if you ever see, with the end behavior, if you ever see this, the little plus, it means you're approaching 0 from the positive side. If you ever see 0 minus, these are pre-cal things, notations. You're approaching 0 from the left. So let's just talk about the end behavior really quick. As x approaches 0 from the right, what's the graph doing? Go ahead and open up your mics. As you approach 0 from the positive direction, what's the graph doing?
Decreasing.
Decrease.
And as you approach infinity, what's the graph doing?
Increasing.
Decreasing.
Bring up forever. Yeah. So I just wanted you to know this notation because I did notice it in my HRW. By the way, in my HRW, some of the problems are requiring different notation than what we do in the classroom. I do want you to be familiar with different things because when you have to take online exams in the future, excuse me, you want to get used to all this quirky stuff. So I do want you to know different ways of writing things. So in my class, I try to be consistent. If you notice on 15.1, there was like, they wanted you to use set notation. Well, we're not using set notation, but it doesn't hurt you to practice. It doesn't hurt you to practice, right? So, and since I'm giving online tests, I can't change it to interval notation. I don't have that ability. So I didn't put a problem like that, by the way, on this exam. So I'm trying to eliminate problems that are going to cause confusion like this. But I do want you to do the online things and look at all the weird things that are going on and be able to adapt. However, if there's errors, let me know. I'm always hesitant about using software when there's errors in there, but let me know if you're having problems like that. Let's do another problem. Anybody have any questions before I erase this? I did have a volunteer, I had a meeting, I had tutoring on Saturday at 9 o'clock with the pre-cal class. And 3 of my students who are failing the class right now joined, and I'm expecting them to get the highest grades in the class. So we were able to go through problems, they were able to ask questions, and it went really well. So make sure that during workshop times or anything else, it seems like you have more exposure to me than ever before. So make sure you take advantage of my time. In addition to that, on Saturday, I was able to share my answer key with them. So I was able to open up their interactive textbook and I was able to show them the even answers. I'm hoping I'll be able to do that with you. So we'll see, but nobody's really asked me about it yet. So. So once again, the parent is the most basic graph. We still have a vertical asymptote at x equals 0 with every parent. So we want to pick 2 points. So we would want to pick our favorite number 1 because log base 2 of 1 is 0. Do you guys notice that this is exactly switched from the exponential growth? So from exponential growth, it's just switched. And that shouldn't surprise you. We've talked about this before. With inverses, things are switching. Ordered pairs are switching. Okay, the next point to pick would be 2, would be a good one, because log base 2 of 2 to the 1 is 1. Okay, so from this, we want to do the transformation. So can you unmute yourself and read this with me, please?
Left one.
Be left one, this would be
Vertical compression by one half.
By one
by
half.
1/2. and
Up to.
Up to. Mhm. Thank you. So left one would be what, 0? And left one would be 1. A vertical compression by 1/2. Vertical means y, so multiply the y by 0 is 0. Multiply by the y by 1/2 is 1/2. Looks like we're going to have to add some fractions in a minute, unfortunately. So now we're going up to, this is easy, and up to here. Now, like I said, on an online test, you might see 2.5. I'm not sure what you're going to see. For me, if you were in the classroom with me, you know that I want to see this as an improper fraction. So I don't know what you're going to see on the exam. So, but you should know how to do either one, is my point. All right, so let's, and then our vertical asymptote, it's affected by H or K? H. Okay, so go ahead, tell me, unmute yourself and tell me, what's the vertical asymptote?
X equals -1.
So I would draw the vertical asymptote. It just provides a good guide for the graph, and then graph the points 0 up to, and then you have right one up 2.5. Just a reminder that the parent graph looks like that. We didn't reflect over the x, we haven't reflected over the y. So the graph's going to look the same. Draw the graph, the vertical asymptote, don't hit it though. So your domain would be what? Open on -1 to infinity, and the range would be forever up and down. I didn't put the domain and range on that column, so you might want to write it in there. I'm going to write it on my notes. So you do want the domain and range in there. The domain is open on -1 to infinity. The range is forever up and down. All right. So in this lesson, you will not be assigned any word problems. In addition, there's a part in the assignment that is asking you about average rate of change. And if you recall, average rate of change is slope. You don't worry about that. I don't want to worry about it right now. So wherever it talks about average rate of change, don't worry about it, just skip it. So you do not have to do average rate of change. All right, so that is the lesson. What I want to do now is take questions from 15.1, since we have time, which I'm really glad about, that I was able to get through the lesson and be able to ask for questions. So let's start with this first. Does anybody have any questions about graphing logarithmic functions?
Ms. Birch, I have a question.
Yeah.
Okay, so why aren't we using horizontal asymptotes, but we're using the vertical asymptotes?
Yeah, good question. We have horizontal asymptotes with exponential growth and decay. So remember back, just previously we had y equals 2 to the x, which was exponential growth, and we had y equals 1/2 to the x, which was exponential decay. These guys have horizontal asymptotes. Okay, right now we're talking about the inverse of these guys. So now we're talking about log base 2 of x and log base 1/2 of x. So the logarithmic functions, since they're the inverses of these guys, they have vertical asymptotes. These guys have horizontal asymptotes at x equals 0 for the parent. The parent of these guys have vertical asymptotes at x equals 0. Sorry, did I say x? These are y equals 0. Did I say, I don't know if I did. These are y equals 0. They're horizontal asymptotes. These guys are vertical asymptotes. So these are horizontal, these are vertical. Okay, was that clear or? Okay, great. Okay, other questions? Any other questions about this? Last call. Okay, what I'm going to do is I'm going to turn off the recording. The recordings, it is taking about a day to upload the recordings, but they are working. They are rough, they are not edited, but the recordings are working, which I'm really grateful for. So, but right now for this, since we're done with the lesson, I'm going to turn off the recording.